we've got two-way encrypted streaming video. It's very exciting stuff. Right, so on this side, we have the IoT endpoint. This is outside the lab. And then over here, we've got encrypted video inside the lab on the 5G network. So essentially what's happening is the camera is taking in the raw video footage. It's being encoded into video on the NUC. Here, this edge compute, there's a XQ proxy there. And I'll go into a bunch of the encryption stuff a little bit later. That's transferred to the IoT gateway, then goes through the network, back over to the MEC, and over to this edge compute device here, which is another NUC, which has an XQ proxy software on it. It's decrypted there, and then it's displayed. On the other side, what happens is that the camera comes in, goes to the proxy, is encrypted, comes back through to the MEC, and it actually doesn't go directly back to this edge compute device, and we'll talk a little bit about why that is in just a moment. So this is the video demo working, and I think now is a really good time to sort of talk about the encryption first and how that's different, and then we can go into like the actual video demo. So encryption up to this point has been either like file-based or VPN-based. So file-based, it's on a per file basis. You hear about security breaches all the time. So the SolarWinds, Bob Flores was just talking about that. And then you've got VPNs, which are fairly safe, but not very scalable. You could have one IoT device with a VPN, but then you move to 100, then you move to 1,000, then you move to 1,000,000. The scalability of that is incredibly difficult. And essentially you're creating like persistent tunnels between each of those devices, which, if they get cracked, all that information comes out, and it's just a difficult thing to manage. We've invented a new API-based architecture, which essentially rekeys everything on the network every few seconds, in some cases every packet, every message based, and has the packets encrypted, the payloads encrypted at the edge, and then the payloads themselves are sent across whatever network that they would normally use, whether it's AWS or a platform that they would use, such as Gmail or Outlook. But the encryption keys and the policies being things like who can read this, when does it expire, that gets stored in the XQ cloud. Now within Indiana specifically, they have their own key cache, their own deployment of XQ. So all of the security keys for everything that happens within this network are stored under their provenance, right? On the other side, what happens is that the data moves through to the other side of the edge. The token is sent back to XQ. We grab that key, provided that all the policies are valid, and decrypt it.